Okay, at this point of the game, you should already know the different types of reactions that exist. So if you were to see any of these examples from day one of notes, you should be able to recognize what a synthesis, decomposition, combustion, single replacement, or double replacement reaction looks like. For example, combustion is made up of a hydrocarbon with oxygen to form carbon dioxide and water. It usually has the little triangle there, which represents change, and in this case, adding heat to the equation. Or there's the other variation of combustion reactions, which would be a metal with an oxygen to form a metal oxide. So when you see only the beginning of a reaction, it should help you by realizing that you yourself can predict the products simply by seeing the beginning. In this case, if we were to have a carbon with a hydrogen and an oxygen, there's the triangle to tell us that it is a combustion reaction. This shows us that the product would be a carbon dioxide and water. So whenever predicting this, we can go ahead and write the CO2 plus H2O. That's our prediction. Next, we can balance the equation. And in this case, since it is a hydrocarbon, you can go back to the balancing rules for a hydrocarbon. You would take the hydrogens, divide them by 2. You get an even number. And if it's even, you would put a 1 in front of the hydrocarbon. That means you'd have 1 carbon on the left, 1 on the right. You can go ahead and put the 1 there. The next to balance would be the hydrogens. You have 4 on the left. In order to make it 4 on the right, you would add a 2 in the front there. Now you would add up the oxygens. You have 2 here and 2 here for a total of 4 on the right. In order for this to equal 4, you can add a 2 in the front. Remember, you can change the coefficients. You cannot change the subscripts. Okay, let's do one more. We have hydrocarbon with oxygen. Automatically, we know it's carbon dioxide with H2O. Next, we're going to balance it. We have hydrogen of 18. Divide the hydrogens by 2. That gives us a 9, which is an odd number, meaning we should put an even number there. This is day 1 of naming, if you need to look at hydrocarbons and naming hydrocarbons, balancing them. Okay, so you'd put the 2 there. This gives you a total of 16 carbon. To get 16 here, you would add the 16 in front on this side. Now you can balance the hydrogens. You have a total of 36 on the left. In order to have 36 on the right, you can add the 18 in front. Now you have a total of 18 oxygens here, but you also have a total of 32 over here, creating 50 oxygens, and to make that balance, you would have to put the 25 on the left. So now they are completely balanced. Okay, next, we have a metal with oxygen creating a metal oxide, so magnesium with oxygen. Now, notice I only put 1 of each element there. There's a good reason for that. Magnesium, if you look at the oxidation state of magnesium, now there's 2 places you could look. You could either look on the ionization chart, which has magnesium here. It tells me that it's a positive 2 charge, and that oxygen is a negative 2. Or if you remember doing this, positive 1, positive 2, positive 3, plus or minus 4, negative 3, negative 2, negative 1. So that would be the negative 2 and the positive 2 for magnesium. But I only put 1 of each because then I would have to do the crisscross for an ionization bond. Now, it is an ionic bond. You do the crisscross, but when you bring the 2 to 2 here, what you would discover is just a 1-to-1 ratio, and therefore you only have to have one magnesium for each oxygen. Now we would balance it. I have 2 oxygens on the left. I'm going to put a 2 in the front here. When I did that, it changed the magnesium to 2, so then I can go back and balance that one. We're done. Let's try aluminum with oxygen. To make it an aluminum oxide, you would have the aluminum, you'd have the oxygen. If you look up the charge of aluminum, you would have a +3 and oxygen is a -2. So +3, -2, you would bring down the crisscross and you'd end up with aluminum oxide. Now we have 2 aluminums on the right. In order to make that balance, I can put a 2 here. For the oxygens, I have 2 on the left and 3 on the right. It's a good idea to do the reciprocal anytime you have a 2 and a 3 combination. So I'm going to put a 2 here and a 3 here to make it a total of 6 oxygens on both sides. But when I did that, it changed the aluminum, and now I have 4 aluminum on the right. I need to go ahead and change that to a 4. Okay, now that we know how to do that, there's one other factor to consider, and that is the state of matter. Are these solids, liquids, or gases? So most of us already know carbon dioxide is a gas that we breathe in, that H2O is a liquid. Okay, so carbon dioxide is a gas and H2O is a liquid. Magnesium oxide and aluminum oxide are a little bit more tricky because we don't exactly know what they are. We do, however, know that they end in oxygen. If you look at the solubility rules chart, which is on the back of your periodic table, okay, it says here, if you look up oxygen, now notice all of these are negative charged ions. Oxygen, it says all oxides are insoluble, meaning they do not dissolve, meaning they would be a solid, except those of 1A elements. 1A elements are right here. Okay, well, in the first example, it's bonded with a 2A element, so that means that it is insoluble.